Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. Today I'm talking with Nick Rabinowitz. Nick is a senior engineer at Foursquare, and today on the podcast he's going to teach us all about big data in the browser. Now the idea of this podcast episode is to give you a little bit of insight into how complicated it actually is. So yeah, we're used to seeing a lot of data in a browser, but I definitely didn't understand how complicated it was, how many decisions needed to be made along the way. And for me personally, this is quite an eye-opening conversation. A couple of things to look out for. We mentioned something called hex tiles in H3. So we've dived into these topics on other podcast episodes. I'll put links to those in the show notes of this episode. And there's a data format called Arrow that I think you'll find interesting. One last thing. So this podcast episode is a part of a series of podcast episodes I've been working on with Foursquare. And again, if you want to check out those other episodes, I'll put links to those in the show notes of the episode you're listening to right now. Okay, that's enough from me. Here's Nick talking about big data in the browser. Hey Nick, welcome to the podcast. Today we're going to be talking about big data in the browser. You are a senior staff engineer at a company called Foursquare, and I know that you have a lot of experience with this. As always, before we dive into the deep end here, would you mind just taking a minute here to introduce yourself to the audience, maybe explain what your role as senior staff engineer at Foursquare is all about, and maybe just a little bit about how you got there?
Thanks, Daniel. So I started at Foursquare about 2 years ago, and I came in as part of a company called Unfolded. And Unfolded focused on geospatial analytics. And, I think of this as we had a lot of analytical capabilities, and Foursquare is a company that has a great deal of geospatial data. You put these two things together, you can really make some amazing products. So I'm a full stack engineer at Foursquare. I work on both the back end and the front end, and lead several projects within the company, including the Hextile project, and work on a variety of things, mostly around Foursquare Studio, which is our flagship analytics product.
So the promise of this episode is this big data in the browser. Why would we want to put big data in a browser? Why would we want to put lots of data in a browser-based application?
It's a great question. So I have been mostly a front end engineer for probably approaching 25 years now. And when I started, there was no real question of having data in the browser at all. You could barely do anything in the browser other than display a web page. And I've been, working iteratively on projects that put more and more things into the browser rather than keeping them in backend systems. And I think the reason for that is that you get a much better user experience and a much more interesting application when the data processing happens really close to the user. When I am, making a query or changing a filter or putting something on a map, if I have to wait for this long round trip that goes back to some server and then comes back, it can be very tedious. And I lack the immediate feedback that I get when something is happening right in the browser. When I think about mapping applications, I started working on mapping applications back when you had mapping applications that just gave you images, and you would press east or north and you would get another image, and that process took a long time. Perhaps some of you are familiar with MapQuest, and that was the experience of mapping applications on the web at the time.
Yeah, I remember that.
And it was a very slow and very painstaking process, even just to navigate to a particular area on the map. Nowadays, and over time, we've been able to put more and more into the browser. So, Google Maps obviously was a great advance in this. And, more and more mapping and data visualization applications have brought data right into the browser, and the processing can happen in the browser. And now when I pan or zoom, that all happens mostly right in my browser. It happens on my own machine, very close to me. And because of that, the response is almost instantaneous. What we work on in Foursquare Studio, one of the main purposes of that application is exploratory data analysis. It's a really iterative process where you're going through lots of different questions, lots of different kinds of analysis. You're putting things on a map and then you're hiding them and putting something else on the map. You are adding a filter and then you're quickly adjusting it. The faster and more fluid that interaction can be, the easier it is to come to insights and to, come up with new questions that might lead you in new directions. And putting the data into the browser, going back to the technology that's involved here, the more of that processing you can do in the browser, the more you can get this really real-time feedback to your actions and to your questions, and you can move around that map in a really fluid way, getting much closer to a clean, iterative process rather than a tedious ask and wait kind of process.
This actually makes a lot of sense to me. As a user of some of these products, I really appreciate that feedback loop. That the quicker it is, feeling like there's something happening. I guess this is why when we set if you're using a Mac, for example, that spinning wheel, it's telling the user, I'm actually doing something here. Something's happening. It's just taking a little bit of time. So I appreciate that where you're coming from in terms of the UI. I want to. This might be slightly off topic here, but do you think about like processing stuff in the browser as being edge computing or like a form of distributed computing?
I do. I was going to get to that point. I think as an engineer, I have what you might call an ulterior motive to wanting things to happen in the browser. The more things happen in the browser, the more I don't need them to happen on my own servers. I don't have to pay for that, and I don't have to worry about whether those servers are running and whether they're working properly, because that's all happening on your machine. So I think of browser-based applications as almost the extreme end of edge computing. We often think of edge computing as moving data and processing, within the network closer and closer to the user. So if you're in San Francisco, I put my servers right in San Francisco and they're running, when you request, you get something right next to you. Well, the closest I can get to is the computer that you're actually working on right now. And so I think of this as a really powerful way of moving the data and the processing and most of the application all the way to your computer while still having all of the affordances and capabilities that you get in a distributed application. So obviously, one option of this, you can just run an application on your own computer. You can keep all the data on your own computer, but then you don't have the ability to offer, all the capabilities of a web-based system, things like collaboration or large scale data processing, things that can't fit into the memory of your own computer. These are things you get out of a distributed system and out of a web based application, but you can leverage those in your own computer when you're running that through a browser based interface.
So I think now would be a really good time to start to maybe break this up a little bit. So we understand that we're talking about big data in the browser. You made some great points of why we might want to do this. I think it's really important to have that sort of that understanding of edge computing, distributed computing into the conversation. But now I think it's probably a right time to break this up and say, well, let's talk about the back end and then let's talk about the front end. For me, in my brain, it makes most sense to talk about the back end first. What kinds of decisions do we need to make to be able to do this efficiently, to be able to get a lot of data into the browser? My guess is we're talking about things like tiling, just as an example, streaming data to the client. But maybe you have some more words or thoughts you can put around this, the decisions we need to make on the back end to make this process effective.
So I think of software engineering as a set of evaluations of different kinds of trade-offs in general. That's one of the most important things I feel like I do as a software engineer. And so when I'm looking at a system that has a backend component or perhaps many backend components and a front-end component that lives in the browser, I'm usually trying to figure out what are the trade-offs between putting something in one place or another. In some cases, there are clear constraints. So probably the most obvious one I alluded to earlier, if you have something, a data set that's too large to fit in the memory of your client, the memory of your browser, then you need to put that data set somewhere on the back end where you can distribute it across many different machines. So that's one really important consideration. Can I actually do this in a client machine at all? I might not be able to. Obviously for very large data sets, you frequently want to put them in the back end. You want to manage them, on a range of different machines. That's partly for parallel processing, but it's also partly just that you need to be able to split up the memory so you never need to deal with more memory than you can actually handle in a single instance. So that's an important consideration. There's a consideration of where you're going to be able to do the processing the fastest. So you might be able to do it, really fast because you can leverage backend coding environments, backend libraries, parallel processing, database systems that are often, highly optimized for parallel processing or for large scale queries. You can leverage all that stuff in the backend. and then, obviously get the results in the front end. You mentioned tiling, and I think that's it's a useful approach, but it's also a useful thing to think about that one of the huge benefits of tiling is that you're only bringing the data that you really need into the front end. Each tile is like a mini data set that you can bring into the front end of your application and use in situ. You can use it exactly where you need it, and then you can get rid of it when you don't need it anymore. So it's a really nice way to manage large data sets. Streaming works in some ways the same way. You stream data into the browser, you see the data that is at your current point in that stream. Streaming was, I think, one of the first applications of streaming was for video streaming. And so you only need, the few frames that you're actually showing in the browser, and then you can get rid of them and get the next frames. Well, you can use the same approach for big data in many cases, especially if you're dealing with certain types of real-time data where the entire data set, that could span years could be enormous. But if you're only looking at the last 20 minutes or in some cases the last month, then that is a very manageable amount of data that you can work with in depth in a very fast and efficient way in the browser. We leverage this a lot in Foursquare Studio. So Foursquare Studio is built on top of the open source project Kepler GL. Kepler GL just took everything right in your browser. There's no backend to it at all. You load the data directly in, and because of that, it has this really fast, really exciting interface. When you attach a backend to that, you have to think about how are you going to get the data back and forth between these different systems, and how are you going to make it feel the same way it felt when all the data was in your browser. So we use a couple different approaches to that. Sometimes we're doing what you might call traditional SQL queries, where you make a query, you load a large amount of data, but a manageable amount of data into the browser, and then you deal with that data by itself in the browser for further iteration. In some cases, we're using tiling approaches. So you mentioned the hex tile technology that we use at Foursquare. And, this is a case where we're bringing in, as I said, these mini data sets, these small partitions from your overall data set, only the ones that you actually need at the time. And then you can work with those as if they were an in-memory data set. So you still get what I think of as the feel of an in-memory data set, but you're working with things that would be too large to manage on the front end.
Do you work with any cloud optimized formats? So I realize, tiles, you could consider them as being cloud optimized in some ways, but what I was thinking about was cogs, for example.
We do support cogs in the application. I believe that they go through a backend system before you load them directly into the browser. So while it's cloud optimized, we're not necessarily requesting directly from the browser. Sometimes you want to do a little bit of processing on the backend or make a nice, tile-based interface for them rather than making range queries directly to the files. But I think it's a really promising approach. This idea that you can have these massive data sets in the cloud and then only request the small area that you're interested in, rather than having to make something like a traditional SQL query. You can basically just ask for a chunk of data and get only that chunk, and you can ask for it by its address in the cloud. We've been looking at other ways we can leverage this. We support cogs directly, but I think that there are other possibilities for cloud optimized formats that we might be able to support in Foursquare Studio that would be potentially really exciting and make a lot of data that was otherwise, I don't want to say trapped in a database, but otherwise stuck in someone's database. You could make it much more accessible to a variety of systems, but to our system in particular.
Can you talk a little bit about some of the decisions you need to make here? So you talked about maybe SQL queries back and forth from the client to the back end, pulling data out that way. You talked about using hex tiles, which is this format that you've developed. And just before we talked about the cloud optimized, cogs, for example. And now when I think about this cloud optimized, I think about like the processing and the aggregation of these data. It has to happen somewhere else because it can't happen on the back end. There's no server involved. Tiling, you've made a lot of decisions when you tile data already about what is going to be available. And when I think about calling, SQL queries, I think, well, that sounds like a lot more of a flexible system that you could create new queries on the fly and send it back and drag data out that way. But for me, there's certain decisions that need to be made at each of those levels. I'm wondering how you think about that.
Yeah, when I look at a given use case, I'm usually looking at a lot of different lot of different questions. There's a question about how fast do we need the data? There's a question about how large the data is likely to get. There's a question about whether data transfer is going to be a significant part of how long it takes to get the data in, or whether we can transfer the data quickly and then rendering the data might take a long time. So I think of this as a pipeline from the back end to the front end. At every stage in the pipeline, you're going to have a different set of affordances, but also a different set of constraints. And you want to pick the right point in the pipeline for things to occur depending on your use case. So one good example here is, if I'm doing a lot of data processing, can I do that data processing once, potentially offline, when the user isn't trying to do something active with it, and then reuse that data again and again? So if you're building a tile set, this is a good example. I might want to build a reusable tile set and then leverage that tile set again and again. The building was the really expensive part, and I had to wait for that to occur. But once it's built, I can use it in a very effective and efficient way. Conversely, if I'm going to be doing a lot of exploration where I need to rebuild and rebuild and rebuild, then maybe a tile set's the wrong approach. Maybe I should be using something more like a SQL query. There's a version of this that we're currently working on where you're making something like a SQL query per tile. And so you get some of the flexibility of a SQL query, but then you're still only dealing with the data you actually care about. This works up to a point. It's never going to be quite as fast as the pre-built tiles you might make otherwise. So a lot of it depends, on what the end user is trying to do, what the data looks like, what the different kinds of analysis you're trying to do might be. So as a really simple example, when you're just adding things up, you often have a lot of ability to do this on the fly. You can add it up at different levels, and then you can, do further work with that. So this works really well for metrics and data that can be easily aggregated like that I think of as additive data. When you're doing something that actually always requires access to the original row level data, for example, counting unique values, that's something that's very hard to do ahead of time. So it's really hard to build a tile set if you want to count a bunch of unique values and then apply a filter and get that count again, because you always have to go back to the underlying data. So I'm often considering both the technical implications of where is this particular process going to run faster? How do I get the data from one place to another? How much can I put into the browser and what can I do there? But I'm also considering what are the actual analytical functions we're going to be applying at one place or another in the system? And how reusable is that data further down the pipeline? I hope that makes a little bit of sense. If I'm dealing with a population data set and I'm just counting it, then I can pretty much send it all the way down the pipeline in aggregate, and I can reuse it in various different ways. But if I'm dealing with a data set that I need to do a lot of careful filtering on at the raw level, I'm going to have to go back again and again to that raw data. And that requires something that looks a lot more like a SQL query in many cases.
It does make a lot of sense. I appreciate you walking us through that. The thing I would say is it's kind of blows me away how complicated this is. So like lots of different data, and it makes me think differently about some of the analytic products that I've used in the past. Lots of different kinds of data. You might have, like you're saying, stuff that makes sense to tile. Do the work up front and then stream it, and you can use it for a lot of different clients, a lot of different use cases. Then maybe you've got a real time data stream, which doesn't make much sense to tile. People need access to it, and they want to be flexible in terms of how they analyze that and create queries on the fly. And yeah, it just makes me realize how complicated all this is to build. And of course, it doesn't get less complicated given that our expectations as users are very high. Like like we talked about at the start, we want to see things happening and we want flexibility and we want it right now. I think a nice sort of segue from moving away from some of the stuff we've been talking about now in the back end and perhaps looking towards the front end would be this idea of serializing data. I realize some people will know exactly what that means, but some people won't. Can we start with that, please? What does that mean to you?
Sure. So anytime you are trying to get data from one part of the system to another, you've got to pick some format that you're going to put that data into, and you've got to send that format over the wire. And in many cases, you will have to do what's called serialization and deserialization. So the data is going to be living somehow in memory in one system, and you might pick a format like GeoJSON or CSV to send on to the next system. That's a format that, will be appropriate for sending over the wire. It's a format that the next system can easily interpret. But depending on what you pick, the cost of serialization and deserialization can be very high. This is something I didn't realize when I first started working as a software developer on this kind of system. But, one of the most expensive things you can do in many cases is to turn some set of data into JSON and then get it back out of JSON in the next system. That handoff between those two systems can be very expensive, not just the sending the data over the wire, but serializing and then deserializing at either end. So, one thing I find really exciting now, and one thing we're using a lot in Foursquare Studio, is data formats like Arrow. So, Arrow is a relatively new data format. It comes out of the Apache Foundation. And the whole concept of Arrow is that the memory format is the same from system to system and programming language to programming language. You don't have to do this serialization and deserialization. You just pass these chunks of memory around, and the next system will know how to interpret that in the same way without having to change it into a native format.
Oh, just so I understand, like, so today, if I had data in a PostGIS database, for example, it's in one format in the database, whatever that might be. I say, hey, I make a query against that database. It gives it to me. It may be on the way. It serializes it into JSON. I take it over into my front end. The JavaScript grabs a hold of it and does something else with it. And then maybe I need to do something else with it if that data needs to go on to the GPU. Is that the kind of thing we're talking about?
Yeah, exactly. So, without getting too much into the weeds, Postgres is going to have one way of representing, a number or a string or, some piece of data in its own memory format. That's going to be really efficient for Postgres. And to get it into the next system, frequently, it's going to have to go through some new format that is not Postgres, the Postgres native format, but is some interchange format like JSON. If you read that into JavaScript, JavaScript is going to loaded into its own in memory representation of those numbers and those strings. The idea with something like Arrow is that instead of sending numbers and strings and having to say, Postgres thinks the number and string looks like this, and JavaScript thinks it looks like this, you just send this set of bytes that goes from one system to the next, and both systems understand how to read that set of bytes without having to reinterpret it into a native memory format. They can just say, I know how to look into this byte and find the number within. And you mentioned the GPU. The ideal here, and I have to say we're not actually there yet in our own system, but it's definitely possible, is that you can take these bytes and move them not only from the back end to the front end, but then from the front end directly into the GPU. You need some interchange format frequently when you are passing data into the GPU or when you're passing data to a web worker, which is another way to get really efficient data processing on the front end. And one of the things that people often complain about when they start working with web workers or when they start working with GPU systems is that you get this great boost of processing speed within the GPU or within a web worker, but you have to pass the data back and forth, and that can be very expensive. When you have something like Arrow, you can pass the data back and forth with very minimal cost, and that's really exciting. That's a relatively new thing within the web engineering community. Something I've also seen recently is databases like DuckDB that use Arrow natively, and so now you have basically an entire database system that you can run either on the front end or on the back end, and it can interpret these files without having to do this expensive serialization and deserialization, and you can leverage it wherever you need it without having to pay this extra cost, which is also from an engineering standpoint is a really exciting thing. And I think while the end user isn't going to be saying, oh, I want to use this system because you're using Arrow, the end user really does benefit because they see that the system is faster, more fluid, easier to work with, and that you just get the answers you want faster rather than having to wait for this long round trip.
Well, thank you very much for going into detail on that. I appreciate it. What did you say that database was called?
DuckDB.
Did you say it was an in-memory format? That Arrow was an in-memory format, or is it is it also a written to disk format for want of a better way of describing it?
So, as I understand it, and this gets a little bit into the weeds, it's both. The format of the file on disk, you can write it to disk, and the format of the file on disk is basically the same representation as you load directly into memory. So that's the big advantage, that rather than reading something like a CSV and then loading it into memory in a totally different format, that, whatever your current system is, your current system knows how to work with a number in this format, and so they move there. Arrow, you can basically just stream the data directly from the file into working memory for your program, and then your working memory has access to this data with a knowledge of what it represents. So with a knowledge that it has these particular columns of numbers and this column of strings and this way of working with these columns. So it's a very efficient way of going from disk to memory and then across the wire to some other system's memory when your browser wants to work with it or your other backend service needs to work with it.
Well, look, I am not an engineer, but even I think that sounds cool. Thanks for walking us through that. I appreciate it. That was great. So now we're over on the client, the front end, the user interface. A client today could be anything. It could be a watch. It could be a very low powered phone. It could be a doorbell. But my guess is that you are only working with very specific kinds of clients when you're building these backends. Firstly, what kinds of clients are you working in, or what is your ideal client? And then I'd like to move off and talk about what we can do within the client, and perhaps specifically what jobs are great for JavaScript and what should we be thinking about using a GPU for. But let's start with that client. Like, what kinds of clients should be working with big data, or can we work with big data?
So as I mentioned, I've been a front end developer for many years, and the worst thing I would say, or the most difficult thing about being a front end developer, is that you never know exactly what machine your code is going to be running on. When you are a back end developer, you can say, I'm going to run it on exactly this kind of cloud instance, or I can even have my own custom hardware and I can set this up exactly the way I want it. When you're a front end developer, as you said, it could be running on a watch, it could be running on someone's phone. I appreciate most data analysis applications because we can make certain assumptions about the end user and the kind of thing they're going to be working with, the kind of machine they'll have available. So we're mostly working with people's desktop or laptop computers, and we're mostly working with a limited set of browsers: Chrome, maybe Safari, maybe a couple of other options. I'm sure some people are using Edge, but you can look at the statistics, and most people, are not going to be using the more esoteric browsers or the more esoteric machines. You could access our application on your phone, but if you're a data analyst, you're very unlikely to do your data analysis on your phone. I hope.
Yeah.
So, but it's interesting because you said, you might design your backend differently. Well, ideally, you design your backend in a way that works for all of these clients, but you're going to design your front end in a different way for these different clients. And one of the things that I think about a lot is, can we take a certain piece of functionality, have it work both on, what I might think of as a high-powered front-end client, working in a Chrome browser with plenty of memory, and I can run it there. And then also, if necessary, I might want to run it on the back end. So we often try to move pieces of functionality back and forth between the back end and the front end, ideally having the same, feature in both cases. Let's say I want to buffer a polygon, or I want to enhance a data set with additional information, basically doing some kind of join. If I can do that on the front end, that's great for all the reasons I've been talking about. It's very fast, it's very clean and efficient for the user. I, as the developer, I don't have to pay for the computation to run that. That's lovely. But if I also want to support mobile clients, or other kinds of limited bandwidth or limited compute power clients, it's great to be able to do that on the back end and just give you the result rather than the data that was necessary to compute the result. And so we try to have both in the systems that I've worked on. I think a lot about, can this piece of functionality work on the back end and the front end? And as I'm building it, that gives me a lot of flexibility as an engineer, both to move that computation back and forth as necessary, and to to not hem myself in on a particular choice. So, the worst the worst kinds of engineering projects I've been on is when we made the wrong choice. We built something on either the front end or the back end, and now we need to build it in the other place. And it's basically, you're rebuilding the entire thing. Whereas if you take sets of functionality, and this works really well when you're working primarily in JavaScript, but there are other ways to do it. You can take a set of functionality and you can run it as needed in the front end and as needed in the back end. The H3 library, actually, which I work on, is a really good example here. We built the H3 library in C, and we built it in C because C is a really portable language. You can tie it into all sorts of other languages, and you can do what's called transpiling, where you basically make a JavaScript program out of your C program. And because of that, we can run anything you want to run about H3, we can run either in a web client or we could run it on the back end. And that gives us this flexibility to work with, either the kind of high powered, high memory MacBook running Chrome situation that many of our current users might have. Or if it comes up that we need a kind of situation where people want to access things quickly on their mobile phone, you could give them the fully rendered image, for example, and have the backend do the rendering. So having these options available is really useful. Often you have to make the choice about whether that's going to be really valuable enough to make things portable across backend and front end systems. But whenever there's an option to do that, as an engineer, I try to look for that because it gives you a lot more flexibility about where in the pipeline these things happen.
Do you ever find yourself in the situation where, oh, look, the memory's full, that this client's really busy, but they've started another process over here. Let's just run that particular one on the back end.
Usually, you don't have the option to decide ahead of time. I've always actually wanted to build a system that would really look at the performance characteristics of the current client and say, wow, this browser is doing a lot of work already. Let's shift the processing somewhere else. To be honest, I've never actually been able to work on that system. I think that usually it's the kind of optimization that we always sort of have in the back of our head and then never actually manage to implement. So usually it's a decision you have to make ahead of time. You have to say, knowing my users, knowing the kinds of things that they're going to be doing and the kinds of machines they might be using, should I put this in the front end or should I put this in the back end? I think the biggest divide there is mobile versus desktop. If you know that people are going to be using mobile, you know already that they've got a smaller screen, they have a little bit less processing power, though increasingly mobile phones also can have a great deal of processing power. They almost certainly have less bandwidth. They might be using it in a really low bandwidth situation, so you don't necessarily want to be moving a great deal of data back and forth. And so you often have to come up with a different option for how to serve those users than you would offer to a desktop user.
What about the situation where we've got two different kinds of users, like the kind of user that is doing analytics, that's exploring data, and the kind of user that is looking at the visualizations that the analytics are producing?
Yeah, so we actually have this situation in our current application in Foursquare Studio. We have, some people who are really, I guess we think of them as creators. They're doing the analysis, they're making maps. They might even be making maps specifically to present to someone else. But then the people who are more consumers, might be in some other part of a company. They might not have any real facility with data analysis, but they want to see the results from the data scientist or the business analyst who made this beautiful map showing you something of value. The way we've approached that is to, I wouldn't say make different applications, but to make, different versions of the same map, perhaps. One of which is fully featured. You have all the bells and whistles, you have all the knobs, you can change it, do all sorts of things with it. And one of which is much more static. We've basically baked that map into a published version that is much faster to load, much more available to, for example, a mobile user, but doesn't have all the capabilities that the desktop, the fully featured sort of desktop exploratory environment is going to offer.
Yeah, so that makes a lot of sense. There's two different users. I guess what I was asking there is there any difference in terms of the technology that you're using both on the client and in the on the back end to serve both those needs?
I think when we're dealing with a published map, for example, we're really trying to keep things as simple as possible. I like to think of it as you want to have the least number of moving parts. So if I can get the whole thing as static as possible while still offering just the degrees of freedom that that user needs, for example, the ability to zoom in and out, to pan around the map, that might be really important. And so you need to still be able, you can't just serve them a static image, perhaps, but I want to basically take away all the things that make our application fully featured and interactive and give them just the elements of interactivity that are going to be necessary for a viewer. I think that's really where I think about it. And the technology, I would say it's usually a reduced subset of the technology that we use for the entire application. But in some cases, we're actually doing something quite different. So, I mean, the extreme example of this is you actually just export a static image of your map, and then that's one publishing option. But I think that, in many other cases, you might simply be loading significantly less of your application into the browser. You might be loading just enough data to show them what they need to see. And you might have pre-processed that data rather than moving all this computation to the front end, for the analyst user who really has, who's expected to have the computational power to do that in their own machine. You might do a lot of that computation ahead of time and then just give them the sort of pre-baked results for a more consumer user who's just interested in seeing that final product. So you might not want to move all that computation down to the client. So again, you're making this choice about, did I do this work in the back end ahead of time, asynchronously, or do I need to do it in the front end in real time in response to user actions? For the publish map, I can really do most of this on our backend. I can do it at the time of publishing rather than at the time of consumption. And having that ability to shift the time scale means that I can give the consumer something really fast, snappy, easy to use on mobile at the cost of less interactivity.
That makes a lot of sense. And thank you very much for going into details there. It really helps me understand. And I'm sure a lot of listeners as well will appreciate that. Part of my long winded question was about, okay, now we're on the front end. What can we do? And I was kind of curious about what can we do in JavaScript and what can we do in the GPU? Could you give me some sort of general guidelines as what technology is best suited to what process or what?
Yeah, it's a great question. I think that it really depends on a lot on your application. So obviously, a GPU is going to be really good at rendering. I used to think of the pipeline of going from your data backend all the way to the front end and all the way to the rendering engine as something that got narrower and narrower as you went down it. So you had fewer and fewer resources at each stage here, and rendering was in many cases, I thought of it as the most expensive thing. This is in the days back when we were using, either static images or SVG to render. When you get into GPU and you can leverage the GPU in the browser, you actually have this ability to do much more efficient and fast rendering. So the end of your pipeline actually gets a lot wider. If you think about it, you have many more resources because GPUs are great at doing parallel processing that's specifically aimed at rendering complex arrays of shapes or colors. The faster you can get the data into the GPU, the more you can leverage the GPU for rendering. What's difficult, and in fact, you can do a certain amount of data processing in the GPU. You can do aggregation, for example, directly in the GPU. It can be very efficient. I've seen this work for things like heat maps or even heat-based grids, where you can do grid-based aggregation directly in the GPU in a very fast and efficient manner. The problem is it's hard to get that data back out. So frequently in a fully fledged data application, you're not only rendering the map, you're also rendering things like a set of charts next to the map or overall metadata about the data you've rendered. Or you need to be able to use the same filter on one part of your data that's been rendered in one way and on the data that's being rendered on the map. So in our system, we leverage the GPU quite a bit for rendering the map. We use a library, an open source library called DeckGL, which is sort of an interface between JavaScript and the GPU and allows us to use a lot of the GPU technology and use shader code, which is a way of basically programming pixel by pixel in a massively parallel way how things should be rendered. We can leverage that directly from JavaScript. But most of the more complicated data processing in many cases actually still happens in JavaScript because it needs to be available to the rest of the application. Otherwise, you end up with the same situation I was alluding to before, where getting the data back and forth actually ends up being the most expensive part of your application. You really want the data processing to happen at the place where it's needed. So if the data processing is about, for example, a map projection, this is actually a great thing for the GPU because the GPU needs to calculate the map projection and then it needs to show it, but nothing else actually needs to know whether this pixel needs to be in this part of the screen or that part of the screen. Only the GPU needs to know, and it can give it directly to your monitor, essentially. Whereas if you're processing something that's not about the visual layout, that's about filtering your data ahead of time, for example, then if you do that on the GPU, you can't easily use it in many other parts of your application. And frequently, as someone who's built these applications before, you might think, oh, I'm only going to need to show it. And you build a proof of concept and it shows up on your screen and you say, this is super fast and efficient. It's great. And then the next five feature requests are all about putting that stuff in some other part of the screen with some other representation. And now I want to print this out. And now I want to send this number to a colleague. And these things get harder and harder to do if you move the data directly into the GPU.
Whew, wow. So if I'm understanding this correctly, like we've got GPU parallel processing. If you put it in there, it's hard to get it out. If you're doing a lot of dynamic things and maybe analytics, these analytical processes, maybe JavaScript's the best place to do that. And it sounds like these things are working in parallel in the client. Am I on the right path?
Yeah. I think there are a lot of ways. I mean, one of the biggest criticisms of JavaScript from the early days is that it's what's called single threaded, which means that the JavaScript in your browser can only really do one thing at a time. And a lot of the more recent approaches to doing data analysis or other kinds of computation in the browser are about trying to work around this single threaded nature. So there's a couple different versions of this. You can have these things called web workers, where you move the data into some other what's called a thread, basically some other process where it can do that processing and it's not bothering the rest of your application. It's not the only thing your application is doing at that time. And so you can parallelize in that way. You can move things into the GPU, which is itself, massively parallel, and it's basically doing computations for all the pixels at once. But it's also, outside the JavaScript space. And so once you move the data into the GPU, the rest of your application can go on doing the things that it's doing. It doesn't have to worry about the processing that's going on in the GPU very much. It won't slow things down. If you've ever been on an application running in a browser and you click a button and suddenly everything stops, nothing is clickable, you can't pan the map anymore, and you're just sitting there waiting for something to happen. In the worst case scenario, you get that little wait pop up that says, this page isn't responding. Do you want to go have a cup of coffee or would you prefer to just close the window? That's the worst case scenario of doing everything in JavaScript. So a lot of what we do in the front end is about finding ways to move out of the main thread, move out of the main process of your application so that the user can keep on working in the application in the way that they would expect while your processing happens somewhere else, be that the GPU or be that in a web worker.
Wow. Yeah, I'm kind of blown away at how complex this is, but it's also fascinating. I guess I've taken a lot of things for granted. That this is my main takeaway so far in this conversation is that when I use these analytical tools, I take it completely for granted. I'm just focusing on my job, and my expectations are pretty high. And maybe this is a good sort of segue into like a line of questioning around like what makes the difference? So we've talked about all these technologies that you use, these different approaches, these decisions that need to be made along the way. What do we do on the background, on the back end? Sorry, what do we do on the front end? In terms of the user experience, what do you think makes the biggest difference? Is it just speed? Do people react better when they see something is happening? But what do you think makes the difference when we think about using big data in the browser in terms of user experience?
It's a great question because there's really a lot of facets to it. In the engineering community, we tend to think of performance as this very easily measurable thing. I run a process, I get an answer, I can measure how many milliseconds it took me to get that answer, and whether it runs faster or slower is the answer to whether I did better or worse as an engineer. And there's a certain, I really like that as an engineer. I like the clean cut nature of deciding whether something is good from a performance standpoint. But when you get into the UI, you actually have, I think, many more things going on from the user's perspective. This question of, can I still do other things while my process is running? Well, that's actually a really important question for the reasons I mentioned earlier. If I click a button and then I can't use the application for 10 seconds, well, it's great that it took 10 seconds instead of 20. But if I can't use the application, I can't even click a button or scroll in 10 seconds. That's really painful for me as a user. So, not blocking the user is one issue. I often think of this idea of experiential performance. Users are much more willing to wait if they can see some kind of progress happening, if they know that something is actually occurring. At the very least, do they see some kind of spinner? Ideally, do they see a progress bar that tells them, you've got this much time left before you can get your answer. Go about your business and it'll be done in this period of time. It's the same way that, you or I would feel perhaps at an auto repair shop. If they never tell you what's going on and you don't know whether your car is going to be ready in 15 minutes or 3 days, that can be very frustrating and makes it very difficult to plan. Well, in a very small, microcosm of that, you get this all the time in a user interface where if I know how long something will take, or if I have some indication that things are going on and I should go about my business, well, that gives me the option to make a micro plan to, go and click the next button or do something else. So I think that ends up being very important to the user experience. I think simply being able to get immediate feedback on certain types of actions and to be able, as a software developer, to give really good clues about which things are going to be immediate and which things aren't. Even just the kinds of affordances we give to a user. So, if I give you a slider, then you're going to expect that as you slide, things will change. But if I give you a button, and then once you press that button, I show a spinner, that tells you something slightly longer has to happen, and you shouldn't expect the result to come right away. Ideally, I can wait a little bit for the result, but I don't expect it to be there right away. So being able to manage user expectations also becomes a really important part of this. And then, because of that, user expectations are shaped not only by your product, but by what every other product does. If someone else's product is doing things twice as fast, or I expect that my map is going to move around when I drag it because every other map does that. Well, then your product had better do that too, because otherwise you're going to be
Yeah.
upsetting these user expectations and and ending up with some very very unhappy users.
I'm thinking of everybody that every GIS user, online map creator that was shaking their fist at Google when they first came out with the Slippy map.
Yeah, and then when they went from the image-based Slippy map, where you zoom in and everything gets really fuzzy, and suddenly we started seeing GPU-based maps. I think Mapbox was really one of the main proponents to this, where you zoom in and things scale beautifully using GPU scaling as you zoom in, and you don't have this weird period of fuzzy image that you used to have in the original Google Slippy maps. Suddenly, everyone's expectations changed. Now you can no longer get away with a purely image-based map because it's going to look kind of old and clunky. And people understand that there's a better user experience available.
Yeah, I can, obviously this pushes the industry forward. This pushes the science, the art, the technology forward, and it's great. But I can see it being frustrating for developers. Is any of this what we've been talking about? Not just the user experience, but like the decisions that you make and the technologies that you use and the front end and the back end. Is any of this unique in any way, shape, or form to geospatial?
It's a great question. I think a lot of it is not unique to geospatial. I've worked in the data visualization space for many years, and many of the problems that people working in data visualization face are very similar to the problems that people face in geospatial. You might be representing a very large number of data points. You might be representing complex geometries. You might need things to respond very quickly to user input. I think that the things that are more unique to geospatial are probably about, well, one, a lot of mapping applications have similar user interfaces and similar concepts that people expect. Two, I think that there's a lot of ecosystem around geospatial that you can't leverage in other kinds of applications. I'm thinking about things like the availability of base maps. You don't have this kind of ecosystem of contextual information in a standard data visualization or business intelligence application, whereas people expect it in a geospatial application. If I showed you a map, but you couldn't see where the cities were, or you couldn't see where major roads were, you couldn't get any contextual information, you would not get as much value out of that map. And without naming names, there are data visualization applications now that are moving into mapping without giving you sufficient context, without having a good base map, without following the basic principles, that we've been used to in geospatial applications. And it's a subpar experience.
When I think about, Foursquare Studio, I think about the sort of visual inspection of data. At least that's what I imagine, like scrolling through things. You talked about sliders, adding filters, and then panning around the data, moving around in it. Do you think, like, is all of this being enabled by the technologies that we've been talking about? Or is it been enabled and we made it available to users? Or did you feel like it was a pull from users saying, hey, figure this out. This is the way I want to interact with my data.
I think it's some of both, to be honest. I think that the availability of new technologies makes this possible. So I mentioned Unfolded, which was the company that I worked at that eventually got acquired by Foursquare. Unfolded was built on top of a set of open source technologies, most of them developed at Uber, which were fairly new, fairly innovative, and allowed us to do things that were hard to do before in terms of displaying really beautiful maps of really large amounts of data with a high degree of interactivity and a high degree of performance. So the technology has definitely made things possible that weren't possible before. But the reason those things were developed was because people had this need to see geospatial data in a much more interactive way and to be able to work with geospatial data in the same way that they were getting used to working with other kinds of data in a data visualization environment and an exploratory analysis environment. People started to see that they could do things with a product like Tableau, for example, which is really good for exploratory data analysis using data visualization. And they might want those same kinds of features in a mapping application. And I think that's where we started when we started looking at, what kinds of features would a user want. Some of what we do now is simply building on, to overuse a phrase, building on the shoulders of giants. There are a lot of different technologies that have grown much more mature over the last 10 years, say, and that now we can leverage in a much easier way where previously, we would have had to build them from scratch and it would have been very difficult. When we use a system like DeckGL, when we use a library like H3, we're building on a whole bunch of work that's already been done. And we can start to imagine new possibilities, both technical and sometimes analytical, that we can leverage by using that technology. I think about this a lot in the context of H3. You may be familiar with H3 as a hexagon based grid system. And we used H3 as one of the pillars of the Studio application, not just because it's a new and fancy technology and because hexagons look great, but because there are actually a whole bunch of analytical things you can do with hexagons that are quite hard to do with traditional data formats. And so we could see that we had this technology, but we also had this conceptual set of ideas, of what you can do with a grid system that you can't really do very easily with vector data or with raster data. And I think that that's been as useful for developing new aspects of this technology as the sort of nuts and bolts of the engineering and the new GPU based technology has been, that you can make these jumps from a technical standpoint, but they're actually often much more interesting when you're making them from a conceptual standpoint. When you have technologies that enable you to think of something that you really hadn't thought you needed before, but now you can leverage in a new way.
Well, I know you said that you don't use H3 just because they're hexagons and they look great. But I mean, it doesn't hurt that there are hexagons and they look great, right?
Oh, it's true. I often think of this, I think it was one of the criticisms that we got early on and probably still get for H3 that, well, people only like hexagons because they look really good. Well, coming from a data visualization background, they look really good because massive amount of our brain is dedicated to visual processing. And so we're really good at recognizing good representations of data because we can see that a hexagon based grid system is going to give you better fidelity and fewer and lower margin of error in many cases than a square grid system would give you. That's why they look good. They look good because we can understand at a very low level in our brains that it's actually a really good way of seeing your data.
I think this is probably a great point to round off the conversation. We've come a long way, and I think you've done a brilliant job of helping me understand this. Hopefully, also helping the listeners understand it. So I really appreciate it. But as always, before I let you go, there'll be someone listening to this that thinks, well, I would like to reach out to this person. I would like to learn more. Where can we send that person? Do you have any links you can share with us? If they want to get a hold of you personally, can they do that?
Yeah, I'm on Twitter, though not as much as I used to be, at nrabinowitz. I'm at nrabinowitz on many platforms. And to check out Foursquare Studio, you can go to studio.foursquare.com today. Sign up is free. You can try it out. You can also go to location.foursquare.com just to find out more about Foursquare's geospatial offerings. We have a lot of things. Foursquare Studio is one of the applications we develop, but there's a lot of interesting things that you might leverage if you're interested in geospatial analytics or geospatial data.
Thanks very much for your time, Nick. I've really enjoyed talking with you.
Thanks for having me, Daniel. I really appreciate it.
I really hope you enjoyed that episode with Nick. And if you're like me, you've just realized that putting a lot of data into a browser is infinitely more complicated than you imagined. And it's interesting too, as a user, so I'm not a developer by any stretch of the imagination, but I use some of these analytical products from time to time. And it's amazing how little I care about all of that thought and effort that has gone into creating these products. What I'm interested in is just getting my work done, doing the thing. I very rarely think about the tiling schema in the background. I never think about, is this an SQL query that's being sent to the back end? Where is the processing happening in the front end? I never think about those things. I don't care that it's complicated to move between different data formats, and I'm not interested in understanding the intricacies of making this work on multiple different clients. Like this all sounds really bad, and please don't misunderstand me. I found this episode or this conversation with Nick fascinating, but it is really interesting to sort of zoom out a little bit and think about but actually when I'm using these products, I'm not fascinated by that at all. I'm fascinated by how fast it works, but I never think about all of the work, all of the effort that goes into making them fast, making them interactive, making them useful for me. So that was a real eye-opener for me. So I mentioned in the introduction that this episode ties in with a bunch of other podcast episodes that we've published previously. There'll be a lot of links in the show notes today. If you're interested in hex tiles, the H3 system, the kinds of data that Foursquare is working with, and this idea of distributed computing or distributing geospatial data, I'll put a bunch of relevant links in the show notes today. Okay, that's it for me. Thanks for tuning in this week. I'll see you again next week. We'll talk then. Bye.